going to look at how these guys are facing. This is negative to positive. Negative to positive. You still remember that. The short side is the negative, the long side is the positive. This is also negative to positive. So the total EMF now, you will now say E total, meaning that the total EMF of the battery is going to be, you are going to negative to positive, so that's positive. So that will be E1 plus, the second one will be positive, E2 plus E3 plus E4. But without wasting time, let's say there's one of them that is looking like this. This one is going from where now? Positive to negative. Abi, then let's call that E5. So we'll do it all at once. Then that will be minus E5. Do you get that? So when you see a connection like this, you have to be careful. Now let's look at this example. You will tell me the value of the EMF. And you will now calculate the current that is flowing in the circuit. So this is a circuit diagram. This is 0.5 volts battery. This is 2 volts battery. Then this is 2 ohms. Then what will be the current flowing in this circuit? Neglecting So, Ocho Emmanuel, what's the answer? What's the answer? 0/2 ohms. And like, what's the current? The current is going to be in ampere. So what's the current flowing in the circuit? You can't see. Sorry. T3. That should be 0.75. You can see from there. Like there. We shall be well with you. We go from techno to the best of phones in your generation. Don't worry, I understand. I understand. When we were in secondary school, calculate all our numbers. I would flip the calculator like this before we were calling. So I understand. And I remember when they started doing all this Chico for that time. We call it home theater. It will ring you and you will be hearing something. Take your time. You will still buy the best of things. So, this is what. So that means my EMF in total is going to be 2 minus 0.5 Abi. The one that is higher will dictate the flow of the current. So which means current will be going this way. So eventually this will be 2, or let's just say E2 minus E 0.5. You understand that? So that's going to be 2 minus 0.5. What would that give us? 1.5 volts. Abi? So now you already know the effective voltage. So to calculate the work done, or the potential difference, what will it be now? So that would be V is equal to IR, and I already know my V, that's 1.5, is equal to I multiplied by 2. So I is equal to 1.5 over 2. That's 0.7. There are some things, yes, there are some things you can always do in your brain. You know, it might not be easy for you to divide 1.5 over 2. your brain would have just quickly seen 15 over 2, and you already know that's like 15 times 10 raised to power minus 1. So 15 over 2 is still easy to think about, and that's 7.5. Then times 10 raised to power minus 1, that's 0.7. All these are things, you don't need to start punching calculators. Immediately you look at it, you already know your answer. Normally, we used to teach how to solve without calculator, but there's no problem, let's move on. So you understand the answer, Emmanuel? Yes. Why did we say 2 minus 0.5 instead of 0.5 minus 2? If you and I, we are pushing ourselves. You are pushing and pushing. The point is that who is more powerful is the one that the direction of the force will go. And it's not about the size now, it's not about how big you are. So definitely if you and I push ourselves, with a like a rain. So that's the thing. The thing is that if you look at this, which battery do you think we overpower the other? We work more. Is the 2, which means this is the one that will determine the direction of the current. In a way, if I can do it this way, let me do something quickly. This way. If I do it that way, I'm going to have, don't worry, 2.0 minus 0.5 minus 2i is equal to 0. People that don't kick off slow would have known what I just did. Now, at the end of the day, this is going to be 1.5 minus 2i is equal to 0. Then 1.5 is going to be equal to 2i. Eventually, I will be 1.5 over 2. This is called Kirchhoff's law. I just applied something. Now, let me do it let me do it the other way around. I went like this. I know what I'm doing, so don't be bothered. Let me do it this way. You will see that what I'll do will be different from what I did, but I'll still get the same answer. Here now, I'm going from here to here. So this one, the 0.5 is now going to be plus 0.5 minus 2.0 minus plus now in the opposite direction. 2i. So eventually I will have everything equal to 0. So here now I'm going to have something like minus 1.5 Abby will be equal to minus 2i. Minus will go. I is going to be 1.5 over 2. So, but without having to think about Kirchhoff's law, because I don't expect that you understand Kirchhoff's law for now. I'll still teach it in this class. And during post-UTME, we lay emphasis on it. But for now, you can assume, an assumption is what I've done here to make it easier, that, the 2 volts will overpower the 0.5 volts. So I expect the current to travel from here to here, shade there. So I'm not allowing it to travel here. So the direction of current here now is going, and is assumed to be this way because of the 2.0. So that's why I'm taking this one as the one. So in the direction of the higher value, subtract it from this, then you have 1.5. So do we all understand what I've done here? Yes. So let's move on. Don't worry yourself about this. I will define Kirchhoff's law soon, and you understand some bits, not everything. So the next thing is, we said something. If you connect them in series like this, and they told you that they have their internal resistance. So let's say this is R1, R2, R3, R4, R5. Forget about the direction now. Internal resistance. So now, to get the total resistance, the resistance here, are they in series or in parallel? Series. And to get resistance in series, what do? You add. So that means that the total internal resistance is going to be your R1 plus R2 plus R3 plus R4 plus R5. Resistance is resistance. I hope you are following. We have done how to do for series and parallel before. So the resistances are in series because of the arrangement. The next thing is that, let's now see when you connect cells in parallel. Cells in parallel. When you connect cells in parallel, that means you're going to have this kind of connection. It's because my sweat has touched the board. That's why the mechanics. I'm not sure. So let's say this is E1, E2. E1 has internal resistance R1, E2 has internal resistance R2, and E3 has internal resistance R3. So let's say that's what we have. We have connected those cells now in parallel. You'll know the difference between this and this. Abi? Yes. So from what we have here, look at them. How do we get the effective resistance? For the EMF, are we going to say 1 over E total is equal to 1 over E1 plus 1 over E2 plus 1 over E3? No. That's the only difference that you have to be careful of. Are you with me? So now, to get the effective EMF, the effective or total EMF is the same. When we're doing for resistors, we said when they are in parallel, that the voltage is always the same. Abi, if you remember, that was on Monday, so we were not taken away. That's mobile. So we said the voltages are always what? The same when they are in parallel. So that means that E total is the same. E1 is the same thing as E2, is the same thing as E3. And you don't connect different EMF in parallel. So this is E total, is the same thing as E1, E2 is the same thing as E3. That's one. So if you see that any one of these guys is 2 volts, this one is 2 volts, this one is also 2 volts. So if you want to do any calculation, you just use one of them because it's the same for all the connection. It's only one that is working. Then, if I have one for the resistance, it will be 1 over R total. Is now going to be 1 over R1 plus 1 over R2 plus 1 over R3. You understand that one? So when resistors are in parallel, that's how you do it. So now, for EMF in parallel, this is how you do it. For EMF in series, this is how you do it. So let's solve the question on that. Let's say I have a diagram like this. So looking at this circuit, let me make it a bit tougher. Now, everything is connected in parallel. Abi, I have internal resistance, I have the voltages of the battery, and I have the external resistances. And I'm going to ask you 2 questions here. 1. Gazali Shogoni, Shaweti Purity. I1, you are going to calculate the current flowing through the 2 ohms. We are going to calculate the current flowing through the 4 ohms. We are going to calculate the total current flowing in the circuit. Those are the questions you have to do. So we are going to calculate the effective current in the circuit. We are going to calculate the first and the second one. So look at it. What do you have? It's over. It's not over. When you give it, it's over. Have you gotten the answer? Those of you standing, there are spaces at the front door. That place not belongs to up now. There's space there. What's that? There's space for one person more now. If not, like sitting. How you sit? Where's the 6th person? Taufiko. Where's Taufiko? Okay, the 2 of them. Shani is Nabila that so that's 2 of them. Even this place, there are 5 here. There are 5 here. There's space for one more person there. And people will be standing. Some of you too like to stand. You don't want to look for space. Have you got the total current? Are you trying? If you follow the things I've talked about before, you should be able to do it. But maybe to make it easier for you, let me change the resistors to 1 ohm. I should leave it. Oh yeah, so let's see what you got. Show me what you got. Are you done? Yes. Who is done? Don't worry, you are already able to work on the solar system to help us to continue to run farm and everything. Although I know alone. You people have done elasticity. Eh? Wheatstone and elasticity. The baby can imagine someone so there's time. But then somewhere can teach it. That's why I indicated it. I too am trying to say now between 2 and 4 that are in parallel with the same current flow through them. No, because they are in parallel, different currents will flow through them. And when I was explaining, I was telling you they can ask you to calculate here, do here, and a whole lot of things. Who has gotten the total current? What's the total current? Or what's I2? You can do them independently actually. Can you do them independently? No. You can't really do them independently. Oh yes, you can do them independently. No, you can't do them independently. Yes, you can do them independently. No, you can't. What's I total first? Oh yeah, you would actually right. At least get I total for me first, yes. Yes, it's possible, it's even easier to get I total. It's the individual that I'm now thinking about, but it's possible. But let's get I total first. I'm trying to think that we can work without the other, but there will be an effect. Let's check it. When you have an internal resistance present, you have EMF present, and you have external resistance, you already know which of the formulas to apply. So the first formula that should come to your mind is that E is going to be equal to I into R plus R. Abi? But now, if you want to apply this formula, it's not just one R that is there, and it's not just this one R. Abi? This R that is there, they are all in parallel. Abi? That means this formula should change to E is going to be E total is going to be I total, R total, R total. Right? So, how will I get this R total? How will I get this small R? How now? Look at it. How will I get the R total? Because they are in parallel, Abi. So I'm going to use 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Is that clear? And that's going to give me 1 over 0.5 plus 1 over 0.5 plus 1 over 0.5. Do you understand what I've done here? So you can say that this is 3 over 0.5, Abi, then 1 over R total. So R total is going to be 0.5 over 3, right? Yes. 0.5 is like 1 over 2 times 1 over 3, Abi. So that's more like saying 1 over 6. That's your R total. Show her okay. So now, let's get the capital R total. They are both also in what? Parallel, Abi. So, in order to do for those ones, what do we do? Then I can see 1 over R total is going to be 1 over R1 plus 1 over R2. And what's 1 over R1? That's 1 over 2 plus 1 over 4. Or you can do that R total is equal to product over sum, Abi. So you can do 4 times 2 over 4 plus 2. And that can be 8 over 6, which is what? 4 over 3. And that's 1.33 whatever. It's the same thing we have done here. So the FCM is 4 times 2. That's going to be 2 plus 1, Abi. Equals 1 over R total equals this. So 1 over R total is equal to 3 over 4. So R total is going to be 4 over 3. which is 1.33 volts. That's what we did there. But this is the shortcut when we are just 2. So now that we have gotten our R total, we have also gotten our small R total. So what's the next thing? We are looking for I total. We need to get E total. So what will be the E total? 2. That's what we meant here. Whenever you connect batteries in parallel, E total is going to be equal to E1, which is the same thing as what? E2, which is the same thing as E3. Shall you get? So E total is still what? Is still 2 volts. If they are in series, that's when you can start adding, subtracting, and all of those things. So now that we know E total, what do we do next? We get our I total. So that means our E total is going to be I total into R total plus small r total. And now we can have 2 is equal to I total into 1.33 plus 0.167. So I total can now be equal to 2 over, what's this in total? 1.49. Then what would that give you? 1 point. So the current flowing in the circuit is 1.34 amperes. Everybody that started the class with us on Monday should understand what I've done. Yes. Except you did not practice yourself. So now that we have gotten this, then we have to look for the current flowing through I2 and the current flowing through I4. The issue I'm just having here is that if the total current is coming, when it gets here to divide, let's say that's the one that will flow through I2, and this is the one that will flow through I4. Relatively, I think we can still do that. Since we already know I total, whatever it is, I total will just divide. But I don't really want to assume so that I don't mislead you. You know, I got the question off hand. I don't want to assume, but my only assumption that could have been, in case you find yourself in a scenario like this, is that okay, if this is the I total and this divides, what would be the potential for this? 2 volts. You know they are in parallel, so this will be 2 volts. And as long as this is 2 volts, you can get the I. Do you get that? So now I can say that V going through 2 is going to be I2 R2. Shall you get? So from there I can say I2 is equal to V going through 2 over R2. So what's V2? 2 over 2, and that's what? 1 ampere. Do you understand that? Therefore the 4, I4 is going to be V4 over R4, and that's going to be 4 over 2. Abby? And that's what? Oh, sorry. I was already looking at it down. 2 over 4 is what? 5. 0.5 ampere. So you see why I said there is a bit of discrepancies. If you add this and this together now, you will get 1.5 Abby. But if you look at what we got here, 1.34. So it should not really be. It should not really be because of these internal resistances that are added. So that's why. So you can neglect this question that I asked, this one. So there's something that is probably wrong due to the internal resistance. Except that we want to still treat them like, oh, if I'm looking for the current through this, then I can now say this is going to be, neglect this one, then let's do this, then that's going to be, when you have a complex circuit like this, we actually use Kirchhoff's law to get for individual. But let me just say that, at least in the example, if you find yourself, what can you think about again? The total EMF 2 will be equal to I, the one I'm looking for, I2. Then 2 plus, then the total internal resistance, 1 over 6. Like this, like saying E I, R, then small r. She gets another way. If you do this and you do 44 and you add them together and you get this, then that means you are probably correct. Do you understand what I'm trying to prove here? But however, you can neglect the question. Just you understand that we got I total. That one is straight, is correct. But that 19192, you can neglect it. But we are just trying to prove that in case. So that's it. So let's leave it there. So let's look at Wheatstone Bridge. So let's look at Wheatstone Bridge. You say you can't see from the back. If you try and move forward, I'm going to increase the way I write. I'm going to increase it. You do not understand here. It's either you are not in class on Monday or you have not read. If there's anybody that did not understand what I've done here, it's either you were not in class on Monday. What I'm doing here, is there anything strange about it in this place? I already told you how to calculate resistances in parallel. Abi, why do we have to treat this one in parallel? Because there are 3 of them, Abi, and the 3 of them are in parallel, and that's why we have to first calculate it in parallel. Do you get that? But for this one, there are 2 of them, and the 2 of them are also what? In parallel, and that's why we have to do for that 2 in parallel. Then the total EMF, I told you anytime EMF is connected in parallel, there is just one of them that is the total. That's what I'm trying to do. So this is like an example. But you can't get this if you did not get most of the things we talked about on Monday. Or you went home and you just closed your book and you are just coming back today. But let's say you are still confused. We'll not be able to explain. So these are formula. Then the E total is 2 because they are in parallel. On Monday I told you that whenever they are connected in parallel, it is the same EMF. Abi, then how do I get my R total? Then I have to do this. How do I get this R total? I have to do this. And that's what we did. Yes.
보자. Vous?
So, can I rub the board now? Eh? You are not through with the board. Oh yeah, be fast. Right. So let's look at Wheatstone Bridge and Meter Bridge. Quickly, are you through with the board? So Wheatstone Bridge is a device used to determine an unknown resistance. So no, it's the same thing I did. Are you through with the board? So let's look at Wheatstone Bridge. Wheatstone Bridge is a device used to determine the value of an unknown resistance. Wheatstone bridge. So for Wheatstone bridge, it is a device that is used to determine the value of an unknown resistance. So they will give you 3 resistors. We don't have to waste much time here. Now, this is how the diagram looks in physics. It's because of those at the back. That's why I'm making it bigger. You have to make it so big in your notes. So this is a Wheatstone bridge. Now, we call this R1, R2, R3, R4. Then there's a cell, EMF. Now, in this kind of setup, they will tell you 3 of it, and they will say you should find 1. So we use this instrument to determine the value of an unknown resistance. Is as we can, there are a lot of proofs we can do. That's why Potentiometer class, if there's enough time, there's always this calmness of, because by that time you would have known all these things. You want to pass JAMB, nothing more. So during Potentiometer, we will now spend more energy on some proofs. We will all be looking at how we got everything together. But for JAMB level, you don't need to disturb yourself. For a circuit like this, what they just, if they can ask you 2 questions. 1, what is the use of Wheatstone bridge? Number 1. So for you now, what do you use Wheatstone bridge to do? To determine an unknown resistance. Number two question they can ask you is that for this Wheatstone bridge to work perfectly, for you to determine the value of an unknown resistance, the galvanometer must show there must be no current. No, you know what's the function of galvanometer? It helps to measure current. So this galvanometer, for you to adjust this thing properly, it must not read any current. Meaning that current must not flow through this center. That's the only thing you need to know. You know that, let me say that this current is coming, everybody. Current is coming. When the current gets here, what will it do? It will divide, Abi. A current will go through I1. Current will also go through I2. When this I1 gets here, what do you expect it to do? To divide now. So once you go through the galvanometer, Abi, and once you go through the 3rd resistor. I hope you are listening. You know there's a junction. So this current that is coming, automatically you will not divide. Part will pass here, part will pass here. But for this thing to work perfectly, it is designed in such a way that the current going through the galvanometer must be 0. Questions have I talked about now? 2. Questions have I talked about now? 2. 1 question, the function, Abi. 2nd question, how it works. There must be no deflection. Meaning that this galvanometer must not read any current. Do you get my point? Then the 3rd question is, they will now give you 3 of these resistors. They will say you should look for 1 of them. So if they say you should look for 1 of them, then this is the formula. Look at the way we apply this formula. Don't cross like this. This is how you apply it. So in order to get the resistance, you will do over like this. You can do like this. You can do like this. But you don't do like this. You get the wrong answer. So to get the unknown resistance now, you will say R1 over R2. The ratio here must balance the ratio here. Is equal to R3 over R4. That's what you will use. You can also say R1 over R3, like you can cross this way. You see that it's the same thing as this. I can say R1 over R3 is equal to R2 over R4. You can see that if you do your cross multiplication, it's still the same thing as this. But you don't say R1 over R4. No, that is wrong. Do you get that? So don't do R1 over R4, R3 over R2. No. It is R1 over R2 equals R3 over R4. Or R1 over R3 is equal to R2 over R4. Or R3 over R1 is equal to R4 over R2. Anyone. But don't cross. Show you what? That's all you need to know. So anytime you see a question on Wheatstone Bridge, this is what they are trying to ask you to do. Those are the 3 questions they can ask you in JAMB. So, let's move on. The only thing is that English might just be different. Then, there's what we, have you written what I've said? Then, the galvanometer must show what? No deflection. And what does no deflection means? No current must flow through the galvanometer. Sometimes you are the one that beats yourself up. I feel like you just need to know some things and move on. At some point, there was a time that I was trying to learn about these things. That was reading so hard. Even someone that graduated from left to left might not get to know this thing. We will just pass and move on. So people connect wire and kilo. But there was time I was trying to get the reason for this. Then I started doing the EMF here, the EMF here. For next thing is when you get to university, ask those that did 100 level, you'll be performing Kirchhoff's law here. And you'll be doing a lot of things over it. So I spent that energy at the point. But for now, don't beat yourself up. R1 over R2 is equal to R3 over R4. That's what you need to do. So, then we now do some experiments in physics lab. We call it meter bridge. So for meter bridge, it works like this guy. But instead of using resistors, it uses a wire. So meter bridge is also used to determine, so right, are you true with this? Meter bridge is a practical application. Of Wheatstone bridge. Meter bridge is a practical application of Wheatstone bridge. It is also used to determine the resistance. Of a material. I begged all of you before that sometimes in learning, it's not everything you get all at once, especially if you are just a starter. There are some classes that I might be in and what they are saying I quickly get it. Because of my growth, my knowledge, not because I'm better than you. It's not because I'm better than you, it's just because I've probably been through it before. So please, don't beat yourself up. You don't understand some things, just keep working harder. It's not everything you get all of a sudden. So, don't stand at the entrance. It is supposed to escape and fresh air coming, so you are being the barrier between them. So, I said meter bridge is what? It's an instrument that works on, it's a practical application of Wheatstone bridge. It is used to determine what? The resistance of a material. So there's a particular material, they just want to know the resistance, then they use meter bridge. So, how does it work? For this one, you have it in the lab. You're going to have your meter bridge connected to a wire. This wire now is of a particular length. L. Let me say that's the length of the wire. Let me take you back to this. R is equal to rho L over A. You remember? Yes. If I have a wire like this, and I say, what's the resistance of this wire? The resistance of this wire depends on one, nature of the material, Abi. What's the nature of this wire? The wire is the same all through, Abi. So the area, if you look at this wire, the size is the same, but there's something I can keep changing, the length, Abi. If I cut it shorter, will the resistance still be the same? But the area still remains the same because it's still the same wire, Abi. The nature of the material is still what? The same. Do you get that? That means I can relate R and length and make this one a constant. So instead of talking about resistance, I can talk about length. So there's a wire now that is connected to this battery. Then I connect that wire to a resistor. I call that R1. Then I connect it to a wire, then to a galvanometer. Just like the way this one operates, then there's a pointer. Then I connect another one, a material X. Then I say it should determine the resistance of that material. Then I connect it this way. Now, what's the difference between this and this? If it by TL to 1, we now call it L. So from here to here, let's call it L1. So I'm relating length now and resistance because it's still the same wire. I'm only checking the distance of the wire. From here to here, let's call it L2. So just the same way we did this, for meter grid to work now, I will keep pointing at the particular point until there will be no deflection. So if there is no deflection, that means this one over this one now balances this one over this one. That's what it just means. So if the now say you should do calculation here, what do? You will just say that R1 over L1, just like we said, R1 over R2, Abi, is equal to R3 over R4. It's as simple as that. So you now say R1 over L1 is equal to what? R2 over L2. So the length, they might now tell you that the length is 100 meters. You will just divide it as appropriate. If they say that it's 60 meters for this one, that means this one will be what? 40 meters. It's as simple as that. Or 40 centimeters. Meter might be very long for 40 meters. So now, that's the formula you use for meter grid. So draw this and write the formula. That's all you need. Now, look at another way they can ask you a question on this guy. When you start solving problems, you see. So when I'm through now, although there are a lot of things I plan that we'll talk about, then we'll solve all of the questions together. Just keep listening and following what I'm doing. So it's not everything that some of you get suddenly all at once, but just keep paying attention. So the next thing is, they could have done it this way. R1, R2, galvanometer, the pointer, the wire of a particular cross-section area, then RS. Then they connect it to the battery. I'm only making it bigger because of those of you that say you can't see at the back. So look at this now. Then let's call this length. 100 minus L. And let's call this L. Do you understand what I did here? Trying to tell you that from here to here is 100. Abi, if from here to here is L, then from here to here will be what? 100 minus L. So now, how do I determine RX here? What do you expect me to do from our piled up experience? Oh yeah, now. What do you expect me to first do here? I'm supposed to first get total resistance, Abi. These two, are they in series or in parallel? So what am I supposed to do? I first do 1 over R total equals 1 over R1 plus 1 over R2. Then that R total now, I will now say R total over 100 minus N equals Rx over N. Do you get that point? That's how it works. Can we move on? Have you written this? So we will solve questions on this, but I'm only trying to show you the possibilities. So the next one to look at is potentiometer. So let's look at potentiometer. Or better still, should I give you a question to quickly solve? So drill. I'm just drawing a diagram. Two ohms resistor and a 4 ohm resistor. They are connected in parallel and to a galvanometer with a jockey to the length of wire. So this length of wire now, the total length is 100 centimeter. Then from here to here, 60 centimeter. So there's a banana here. You should look for the resistance of the banana. After finding it, you eat it. So that's the setup. So you have to find Rx. Oh yeah, everybody should be able to do that. This is JAMB class. And just get all the important things you need to know that they can ask you, and you move on. When you now start solving questions, if there's a bit of problem, then you can solve that too. Are you done? So after talking about what's it called? After talking about potentiometer, I'll quickly introduce you to Kirchhoff's law. Then after Kirchhoff's law, then I will explain application, basic application. Then time permitting, then we'll start solving problems on everything. That'll be all on electricity. So what's your answer? 0 points. Did you all get that? So, this person is asking for chemical equilibrium. That's what will happen to, he wants to know when they say that increase in temperature, we shift it to the left or shift it to the right. So the person wants to know about chemical equilibrium. It's very simple. All these things are very simple. I wish that someone will do it. You just pay attention. There are topics that I'm sure that someone will handle well. More than any teacher. So those taking you chemistry we have to it. Those, even if I'm not around, I have enough people in this class that will teach that. That's why I trust them more than some other persons outside. So you should be able to solve this question, but someone sent it, maybe from your past question. They said that 4 cells each of, I'm going to dictate it for you, so you will all write it. Were you through with this? Yes. Oh yeah, be fast, those doing it. What's the final answer? 0.88. Did you all get that? If you did not get it, talk so I can quickly solve it. So, for these guys now, you know they are in parallel. And you know you are supposed to do whatever is here over whatever is here, Abi, equal to whatever is here over whatever is here, Abi. But now, how do you get whatever is here? One ti di méjì, one lè di mẹ́ta, one lè di mẹ́rin. So, tó bá ṣe wọ́n báyìí, what are you supposed to do? First join them together, someone there you come, Abi. How do you make them one? They are connected in parallel, so you make it one. So how do you make it one? You will say that 1 over R total is equal to 1 over R1 plus 1 over R2. Abi? And that means 1 over 2 plus 1 over 4. That's 1 over R total. And so your 1 over R total is going to be 4. That's 2. Abi? 2 in 4, 2. 2 times 1, 2. Plus 4 in 4, 1. 1 times 1. So here you get, that's 3 over 4. Can you see the board? I'm trying to make it bigger. So now 1 over R total cannot be equal to 3 over 4. So R total will be equal to 4 over 3. Here you get, and that's what? 1.33 ohms. So meaning that we have turned these two now, we have turned them to 1. So you can now say R parallel over 60 over L1 is equal to Rx over L2. Abi? So these guys are the R parallel. That's what? 1.33 over. You already know that place is 60. You don't need to convert it because centimeter will cancel out centimeter. So that will be equal to Rx over. What would that place be now? 40. Show you. So now, this is centimeter, this centimeter, so they will cancel. That's why, don't just cancel anyhow. Multiple during really man lobby, that is over. And when it is over, you can cancel. That's why we don't need to convert. If you convert, you still get the same thing. So now, Rx is eventually going to be 40 times 1.33 all over 60. So what would that give you? 0.88 ohms. So the resistance of that material is 0.88 ohms. Are we clear? Oh yeah, everybody write this question. Quickly, please. 4 cells. Mary, 4 cells. Each of EMF 1.5 volts. Each of the cells is 1.5 volts. 4 cells, each of EMF 1.5 volts. And internal resistance of 4 ohms. Are connected in parallel. Even you have to be smart. I'll give you something and I will ask you that what's the answer. So, right, internal resistance of 4 ohms are connected in parallel. Full stop. What is the effective EMF? What is the effective EMF and internal resistance of the combination? What is the effective EMF and internal resistance of the combination? A. Option A. 6 volts, 16 ohms. 6 volts, 16 ohms. And I used to do this in the exam most times too. I'll tell you what I used to do. Option A. 6 ohms and what? 16 ohms. 6 volts and 16 ohms. Option B. 6 volts, 1 ohm. That means 6 volts and 1 ohm. Option A says that 6 volts, 16 ohms. Option B says that 6 volts, 1 ohm. Option C says that 1.5 volts and 4 ohms. Option D says that 1.45 volts and 1 ohms. Now, you can solve it. But listen to me, without solving it at all, what do you think your answer should be? What reason? What's the reason it should be D? They are in parallel. Pelumi, can you tell me, stand up, can you tell me why they have chosen D as the answer? Or your own answer is not D? Don't solve anything. Look at the question. 4 cells are connected in parallel, and each of them is 1.5 volts, and each of them carries the resistance of 4 ohms. They now say that what is the total EMF and what is the total resistance? From what I've been saying since morning or since Monday, ordinarily looking at it, you should be able to tell your answer even without solving. It's one of the ways to be smart in the exam. So, and you have to work on everything. It's not everything that you have to start solving. So that a lot of times you have 2 hours for your exam, and you will still have like 15 minutes left for the expiry, and that 15 minutes you will not be listening. So, looking at what we have here, why is it that they said the answer is D? What can you say? Be fast, be fast. The effective EMF is 1.5. It's connected to the same. Use proper term. The question already told you the term.
The 4 cells they are connected to.
The 4 cells are connected in parallel, and whenever they are connected in parallel, the EMF is always the same. Abby, I've said that today. Now, why is the answer 1 ohm? Why will you just think the answer is 1 ohm without solving? What reason can you give me? We said that on Monday. Why is the answer 1 ohm? You have to be smart. You can't just be reading and reading and reading and reading and not try to work on yourself to be smart. I talked about it on Monday. So everybody, why is our answer 1 ohm? Because the effective resistance in parallel is always lesser than individual resistance. Abi, I said that on Monday. I said if they are in series, the effective resistance will be higher than individual. But if they are in parallel, it is always lesser than. So, and they gave us individual to be 4. Our final answer can never be 4. We must be lesser. We already know this. We already know the answer should be 1.5 volts. Abi, meaning that we have eliminated this. Then you now go to the option, it's 4 ohms and 1 ohms. And you already know that, oh, if I calculate this thing, my answer should be lesser than 4. So my answer is this, so I'm not solving anything. Do you get it? Then, the second thing I used to do in the exam is this. When I don't know the answer to something, and I look at all of the options, I do elimination. I don't know the answer, I don't even know what to do here at all. If I'm to eliminate, this option B, option A and option B both carry 6 volts, Abi. Option C and D carry 1.5, so there's nothing I can eliminate there because they balance, Abi. But look at option A, option C, option D and option B. Option B carries 1 ohm. Option D also carries 1 ohm. Option A carries 16 and 4, and we automatically eliminate this guy, that they are not the answer. I don't know if you understand what I'm saying. Logically, I don't know anything on me more, but from what I can see here, the fact that 1 ohm could repeat itself twice, meaning that 1 ohm is likely to be the answer. Your problem will not be a way to move. eliminated you. But at the end of the day, you have eliminated two. And you do it in Who Wants to Be a Millionaire. So the 50-50 is still better than everything. You can now guess. The problem some of you might now have is that 1.5, 1.5. And the answer now still be 1.5. You now go and say, 6 no matter, only one should combine it with 6. I come with 6. Our bosses and our amount of actually request the answer is 1.5. And 1.5 how 6 in now they combine 1.5. Our should calculation. So it's as simple as it is. Please, do we understand that? But can we solve it now? For the sake of those that are just learning. So that's why I want to solve it. Some things are logical. But no, that's why sometimes they teach you logics, they teach you sense. And the funniest thing is that if you don't even know book, you can't know logic. That's the thing. So far, no with the logic. Why would you look at something and you start observing, start reading? Because in your brain, a lot of things are working as you are looking at it. But what we know we don't follow not the best. So people to marry themselves. So it's just the way it is. So from what we have, they said 4 cells. The first one, the second one, the third one, and the fourth one. They are all connected like this in parallel. And they said that E1 is 1.5 volts. The internal resistance is 4 ohms. E2 is also 1.5 volts. Then internal resistance is also 4 ohms. E3 is 1.5 volts. Then the internal resistance R3 is also 4 ohms. So the question now is calculate the total EMF. And I told you that E total is still going to be equal to E1. Any one of them is equal to E2 is equal to E3. So meaning that my E total is still what? 1.5 volts. That's the answer. Then the next thing is all of them are connected in parallel. So how do we get their parallel connection? That's going to be 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. And it's easier to solve this one because 1 over 4 plus 1 over 4 plus 1 over 4. Oh, there are 4 of them. Abby? 1, 2, 3. I didn't add the last one. So this is the last one. E4 is equal to 1.5 volts. Then R4 is equal to 4 volts. So that's equal to equal to 1 over R4. So now that there are 4 of them, even though even when I guess that the answer was this, I already solved it again in my brain. Even after guessing, I already know this the answer. But I already wrote 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. So there are 4, 1 over 4. 4 by 4, that's 1. I already know my answer is 1. Even in my brain, without solving. So it's not everything, but so at the end of the day, this is going to be what? 4, 1 over 4. There are 4 of them. So that's 1 over R total. So and that's what? 4 over 4. And that's going to be what? 1. So if you cross multiply, R total is going to be 1 ohm. And that's how we got 1. Is that okay now? I would have said that. So someone said that for the combination of cells in series, how do we know how to add and subtract? Should I showed you from the diagram the other time? For series, One is like this. One is like, for this one, total 3 peg is not going to work again. One is like this. From what you have here, this one is negative to positive. Negative to positive. This one is positive to negative. So if you are going this way, then this will be taken as E1 will be positive, E2 will be positive. But when you get to E3, because you are going this way, then E3 will be taken as negative. But if you are coming this way, E3 will be taken as positive, E2 will be taken as negative, and E1 will be taken as negative. You will still get the same answer. That's why I said you can come this way, you can come this way. But your value should not be negative. The final answer for the year. Ìwà ti ní pé ilé pọ̀ jù ní ìlọ. If this one is 10 and this one is 2, this one is 2, effective will eventually be 6. It will be 6. Shey you get? But if you come this way now, you are going to get something like -6. But if you come this way, you are going to get +6. You always walk in the direction of the higher value. Shey you get? So that you get the positive answer. Your brain will tell you that. But there's a law you can follow. But you don't need to complicate that for now. So I think I've answered that question. I always say that you should give your papers to you. So you know when to add depending on the direction of the currents. That will tell you. And again, your brain can also tell you. Yes. What's the next thing I said we want to talk about? Potentiometer. So right. Because there is no ideal voltmeter. Because there is no ideal voltmeter. Because there is no ideal voltmeter. Because there is no ideal voltmeter, open a bracket. Voltmeter draws current, close the bracket. Because there is no ideal voltmeter, then open a bracket. Voltmeter draws current, then close the bracket. Because there is no ideal voltmeter, in measuring potential difference. In measuring potential difference, there is need for another instrument that does not draw current. In measuring potential difference, there is need for another instrument that does not draw current. In order to measure EMF accurately, there is need for another instrument that does not draw currents. In order to measure EMF or potential difference accurately. Full stop. This is where potentiometer is used. This is when potentiometer is used. Potentiometer. So, I told you something on Monday that we use voltmeter to measure potential difference. And this voltmeter, I said there's an error. Because of the way it's always connected, it's used to draw current, and if you draw current, you won't be able to determine that EMF accurately, that potential difference accurately. So in order to now avoid that error, we need another instrument. So potentiometer is an instrument that helps us to determine It helps us to determine EMF of a cell. EMF and internal resistance of a cell. So this is an instrument used to determine the EMF and internal resistance of a cell. So you put it that way. Now, how do we determine that? The formula is simple. When you have potentiometer, in this scenario now, so there is a cell E1 connected to a length of wire. This length of wire measures from here to here, and let's call that L. Now listen, from what we have said, I said some things that we remember that V is equal to IR. But if I'm using a wire of a constant area and resistivity, I can say that my R is equal to rho L over A. I can make this guy a constant, meaning that my R can be equal to L. I can simply say something like R is directly related to L. So instead of saying V is equal to IR, I can still say V is equal to IL and just say. Now, from what I have there, my E, which is like V now, can be equal to IL, so to say. Then, I already know this E1, I know the L. Let me call it L1, or the total length. Then, I connect it to another EMF to balance out. This one now is connected to a galvanometer. Then I connected it to a slider or a jockey. Then let's call this E2. So you take this slider, you keep using it to touch the length of the wire at the point. As you are touching it, we do this in practicals a lot. So as you are touching this, there will be a stage that the current that is flowing in the galvanometer will be equal to 0. At that point now, that means what is happening down here balances what is happening up. So there will be no current flow. And you don't need to disturb yourself. At that point of the contact, where I is equal to 0, then you take the measurement of the length of the wire. So all you need to know is that E is directly related to L now. If there is no current flowing now, the current through the galvanometer is 0. When IG is equal to 0. And when IG is equal to 0, we usually give it a term. We call it null deflection. So from here I can say that my E is equal to KL. I can say E1 over L1 is equal to E2 over L2. Just like what we did for resistance. It's the same thing. So for potentiometer, the EMF is directly related to the length of the wire. So just know that E1 over L1 is equal to E2 over L2. That's all you need to know. Then another, so there are 3 questions here now. 4. What do you use potentiometer to do? To determine the EMF of a cell. So we want to know E2, we know E1, we know L1. Then when we start touching, we can put ruler to measure L2. Then we now do the calculations and we calculate E2. So you will now realize that you can know the value of this battery. The value. You already know this value of this battery, but there's a battery that you don't know accurately. That one that will measure, instead of measuring 12 volts, you can measure 11.4. That 12 volts is what you will get here. So you have avoided that error that happened that time with voltmeter. Are you there?
Yes.
So now, this is all you just need for that. Nothing much. So the first question is, what is the use of a potentiometer? It is used to determine the EMF of a cell or a battery. Another use is that it can also be used to determine the internal resistance of a battery. That's indirectly. Then, when will it work well? When the galvanometer shows no deflection, meaning that when current is not flowing through the galvanometer. Then another question is, determine the length, determine the EMF, determine blah blah blah. So sometimes this part of the cell can be called the primary cell. Primary cell, the one you know, while the other one that you don't know can be called secondary cell. So, okay. So that's it. That's it. It's straightforward. Sometimes question can be tricky, but it's still straightforward. Maybe you solve those ones in landlord. Right. Are you true? So are you through with this? We'll see question later on that. So let's solve this question as given to us by one of our Lord. So can I draw the diagram? Can I rub this guy? I'm making my writing big because of those of you at the back. So that's why I need to be rubbing the board often. Can I rub this part? Oh, God is an awesome God. Oh, God is an awesome God. Oh, God is an awesome God. So you have to get the effective resistance of this circuit. A resistor network is shown in the figure. What is the equivalent resistance between points A and B? So what is the resistance between points A and B? So let's start from A. You start coming from A. You are going to B. As the current is flowing, how will you know the ones in parallel? The moment you get here, the current will be divided. So there will be a current flowing through here, a current flowing through here. That means this guy and this guy are what? In parallel. But the same current that goes through this, do you know it's the one that will go through this? And it's the one that will go through this. Then when it comes here, the one that is coming, let me say I3, I6. I3 and I6 will join again to form, let's say this is I1. They will come back to form I1. So, can you see it now? So how do we solve it? What do you think? If you reason and you look deeply. I1, current divided. But this guy, they are what? In series. Then when you get here, I3 and I6 will go out to give I1 again. If this is 10 ampere and this is 4, this is 6. When they come here, they will eventually give 10 again. Sure you get, because they will join together, then they continue. Which means that if you are to deal with this problem, first solve these three that are in series. These three that is the same current that is passing through them, you can solve them in series. After solving these three in series, these three will now be in parallel with this guy. Then you will now solve that effective resistance, you will now solve it in parallel with this. Then after solving it in parallel with this, then it will now come to just 3 or 4. Then the rest will now be solved again in series. So you will do our parallel from my analysis. You will do our series first. That's the first one. That means you do this guy, and this guy. Sure you get. Then after doing the three of them, you will restructure your circuits. You will see the way to look again. Oh yeah, let's take it one by one. Oh yeah, let's do this. For the series, how do we do it? We had Abby. That means for our series now, it's going to be 1 plus 5 plus 3. Abby, that's going to be what? 9 ohms. Show you. Now, everything now here gives me 9 ohms. Let me redraw the diagram, but I might not make it too big. So now, I have the 4 ohms. Then I have the 2 ohms. Sure you are following. Then I have the 9 ohms. Then I have the 6 ohms. If you follow through very well, you will see what I'm drawing. Then I have the 8 ohms. Do you agree to this? What I'm doing wrong? We have to simplify this guy. Because these 3 guys, the same currents that pass through them. So they are said to be in series altogether. Show you, then from there we go 9. But look at this diagram again. Is there a way we can simplify it? Yes. The current that is coming, you know we are going from A to B. So the current that is coming, when it gets here, it will still divide. But it is still I6 that will pass through this one, Abby. Then whatever we label that one, I3. Abby, we call this I1. Which means that This guy and this guy, are they in series or parallel? Parallel. So what do? You solve them to series. Abi? So let's solve for them. So let's use for R parallel now. Let's use products over sum. Abi? Because they are just 2. They can say 9 times 2 over 9 plus 2. 9 times 2 over Abi? What would that give us? 1.63 ohms. Abi? Which means that I'll simplify it again. So my diagram will now eventually look like this. The 4 ohms, the 1.63 ohms, Abi, and the 6. Let me just be this way. It's still the same thing. 6 ohms. And what's that last one? 8 ohms. And that's terminal B. That's terminal A. Do you understand that? So what do I have left now? Everything is now in series again. Abi? I only straighten this one because as I've done it now, some of you will be confused again. It's the same thing as here, more straight wire. The fact that the wire is straight like this does not mean you cannot coil it anyhow. She gets. So now, what will be our final answer? So we'll now do for our series, Abi. So our series will now be equal to 4 plus 1.363 plus 6 plus 8. And what would that be in total? 63. So that would be 19.63 ohms. It's not there. It's not there. 40.4. Where is the error? And that's how the diagram is. Can I see the question?
Where's the paper? Put them out. Look at what she show me the any like city like. Is there any like baby girl? Look at this. The moment look at it. Look at
what we have here. If I put anything here, is it the same as what I had before? No. You know that this one is no longer going to be in series with this guy. Yes. Because this IC that is coming, provided by it's a divide. So that means this guy is not in series with them. So with and what divides here, provided by over join the so they that one. But they no. At this point to no. So this guy and this guy will be in parallel. But this guy and this guy will be in series. So you will solve this one first. You will solve this one. You will now solve this one. Then you will solve this one. Then you will now solve everything. This guy is series. That's it. These guys are in parallel. You will solve them. Then this guy and this guy, they are not in series. You solve them. Then this guy and this guy, you solve them. Then everything is now in series. But without that, let me remove this one. Let's see if we get the answer now. Let's see. But this is the answer for this. This one you gave me. So can we? Is this question for this? Why don't calculate RS and R total in parallel and calculate the rest itself? I don't really understand. You just follow the sequence. You just follow. Change it. I really do not understand your question. Why do we not calculate RS? One of the things that people should be certain about is your ability to speak. It's very important. Speak bad English. Ask terrible questions, but with sense. What I'm just saying about the terrible question is let it not make sense to everybody. You are asking that, why is this one looking like W? Why is it not? The unit is ohms. We call it ohms in Greek word. A relevant question. Don't say that, sir, why is your handwriting looking like west and south? Now you are asking a stupid question. So, but you can stand up. Why can't we first? That's the way you start building yourself. All this writing paper, oh mama bello, you cannot even speak in public. You have to train yourself. It's part of it. You will get to university, you will be doing presentations every time. You will stand in front of professors and you will present to them. You have to build yourself. And the thing is that one of the problems many of you to have is that you don't always want corrections in life. That's where the problem is. Make mistakes, let them correct you. Just try your best to be mature. Some people can correct you destructively because I want to know. But some people will correct you constructively. They will try to. And correction can be painful. Can be painful at times. Especially when people are correcting you. But to take that mind of humility also to understand that, oh, they are correcting me. And you try your best to adjust. Not to be vexing at the person that is correcting you. If I correct you the first time, correct you the second time, correct you the third time, and I see that you always angry every time I correct you, I will leave you to your way. I will leave you to your way. So, you have been corrected. A lot of us have been taught to stand up, ask your question. Everybody should keep quiet. The question you ask now, why did we not do arrest? Maybe I could have even learned from it. But now you cannot even stand up to talk. And now I don't understand your paper. So please, learn to speak. Learn to be bold. It's part of learning. Learn to be bold. Learn to speak. Learn to have confidence. Even facing the exam is still with confidence. If I go and write the exam today now, I'll face shake small or more. But I will not find a way to calm myself down and I will face it. So it's not everybody has that spirit of fear. There are sometimes that when they even rise me up to ask me questions, I will be shaking like, oh, I don't really want to talk. But it's normal. You will overcome it. Most of my presentation is really, that's why I have to learn a lot of things. You will reach there. Please, do you understand this now? This is a question. So let's solve another one. The one that she now supposed to give you. Let's see if we get the answer. So now it's crossed like this. The only thing I've added is this guy. She gets. Oh yeah, let's do that one. First thing is, let's look at it. How are we supposed to do it? Look at the way the current is coming, Abby. When the current gets to this junction, what will happen? Meaning that you can't treat this one the same way you will treat this. Because the current going through this is different from the current going through this. But now, as this current is going, it's the same current that goes through this that will go through this, Abby. But when they get here, it will divide again. So meaning that when I6 gets here now, it will divide. Let's change it to I5, Abby. Then it will go like this. Whatever that one is, let's just call it. It's not I4, it's the same I1 that will pass through I6, I4. So let me just call it I3 or something. I2. But when this one comes out here, and this one is also coming to come out here. So I5, I3 will be equal to I1. Yes. The I5 as is coming, when it gets here, I3 is coming. So when they get here, they will join together, Abby, and form I1. Then I1 will come down. As I1 is coming down, it will meet with I2, and it will all come down as. This one is no longer going to be described as I1. Let me call it I4. The one that will pass through this guy. She gets. It was because of what we analyzed before. That's why we say this I1 is still the same thing as this. But now it will now come out as I1. So let's follow the direction of the current again. I1. When I1 got here, what happened? It divided to give us I6 and I3. And labeling it is because this guy is R6. So I6. What current will pass through this one? I6. She gets. So as the I6 is coming, when I6 gets here, it will also divide. A part will come here, a part will come here. Abby, they might have told you something about this in the question. That current cannot flow through here. You know. But for now, it will flow. So this gives you I5. It's no longer I6 because it will divide and I2. Meaning that I6 is equal to I5 plus I2. Then when I5 gets here, I3 is getting here. So I3 and I5 will give us I4. Abby, then I4 comes here, meaning that I4 and I2 will give us back I1. Then the journey begins again. Do you get that? So what are we supposed to do now? First do the one that's the same current. That's so we do our RS. So we do RS to be equal to 1 plus 7. 1 plus 5, Abby. That's 6 volts. Now we have simplified it. But if you look at the simplification, if you say this one are in parallel, yes. But this one, they're also in parallel. So, and since it's almost like the same kind of connection here, I can join this guy and this guy together. So joining this guy and this guy together will give me one thing. Both of them are in parallel, Abby. So let me solve that parallel now. So I can say our parallel is equal to 6 times 3 over 6 plus 3. That's what? 6 times 3 is what? 18 over 9. And that's what? Abby? Yes. Meaning that this one now and this one now in series. Do you get that? I don't want to start drawing the diagram again. So you continue. For the first one, I still have 4. Let me just be straight now that this is now 2 adding. Then this is 8. But there is still this wire. So this one is now 6. Do you agree to that? That's what we have done so far. From there now, this guy are now what? Series. So we can reduce that one. So we can now say our series is equal to 2 plus 2. And that's 4 ohms. Show you. So meaning that this becomes 4. Show you man. So I can now do these two guys in what? So I can do our parallel. 6 over 6 plus 4. And that would be what? 24 over. And that would be what? Abby? So that means I've reduced this now. So then what else now? Series, Abby. 2.4 plus 8. What would that be? 14.4. I drew my one. So you can see that one side is different. So you are the one that. Not because I know what I'm doing, I would have been looking at it and saying, why is the answer not there? So please, that's how to solve this. The answer will be 14.4 volts. So you can see that simple thing I taught you. Simple thing that I just used to. How to connect two in parallel. Or not to solve the complex stories in my lower. And that's why when you keep solving questions, your brain will be open. So you cannot just leave it to class alone. You have to, it's not about coming to class over and over. It's about solving questions over and over. I still have so many things to teach you, so let me still do this. Over. These currents for me, the one divided. That's why we can't treat things like this. But when you look at this one that you are saying you should treat with this, I3, I6, this I5 still came here. So it will not work. It will not work that way. If you follow the trend, you see that it will not work. So please, it's okay. It's okay. What's 18 over 9? Eh? So I don't know. You said, sir, you have made mistake. The RP here, that 2 we got, you said is wrong. Sir, if we use the normal method, we'll get 1 over 2, not 2. It's one that is making mistake. If you use the normal method, we still get the same answer. This one is just a paper method. Is now your own will give you 1 over total equals 9 over 18. Then you now cross multiply. Our total will be 18 over 9. So you get 2. So what else? Oh yeah, let's define Kirchhoff's law. Kirchhoff's law of Kirchhoff. What's your Kirchhoff? Can I help? Kirchhoff's first law. Kirchhoff's first law. This is also known as the law of conservation of charges. This is also known as the law of conservation of charges, which states that the total charge entering a junction, will be equal to the total charge or current. Leaving the junction. We applied that when we're solving this question. The total charge entering the junction will be equal to the total charge leaving the junction. So, from what we have, I did something the other time that
let's say that
let's say that I have these circuits. Let me make it simple. I'll just use a simple circuit diagram to explain it to you. It's something we have been doing since, so it's something you know. So Kirchhoff's law made us to know that the total current that enters the junction will be equal to the total current leaving the junction. From here now, what's the current entering this junction? I total. Abi? So I total will be equal to, what are the currents leaving the junction? I1 and I2 will be equal to I1 plus I2. Better still, the one entering the junction, you can give it a positive value. While the one leaving the junction, you can give it a negative value. So they can say that I total minus I1 minus I2 is equal to 0. So, don't write here too. Meaning that the sum of all the currents, putting directions into consideration, will be equal to 0. The current entering and the current leaving, when you consider their direction and you sum everything together, it will be equal to 0.
So,
That is what this one is. The one entering is assigned positive. The one leaving is assigned negative. Then you sum everything together, they will be equal to 0. Abi? So, or you can still say IT is equal to I1 plus I2. So right. The sum of the currents entering and leaving a junction, the sum of the currents entering and leaving a junction, putting directions into consideration. The sum of the currents entering and leaving a junction, putting directions into consideration, will be equal to 0. Will be equal to 0. Will be equal to 0. So you can now write this. So they can ask you, I think they asked me in my own exam during JAMB, or it was during mock, that the Kirchhoff's first law is also known as which law? Law of conservation of charge. Is the second law that is the law of conservation of energy. So the first law is law of conservation of charges. So I want us to have enough time for the chemistry today, to end the chemistry. So please, you can go for your break now. So by 12, you come back for chemistry. So you can have from 12 to 1:30 for the chemistry. So, or you don't want to go on break, you should continue chemistry. So go for your break. So 12 to 1:30, we will have chemistry. Thank you. I'll continue from there in my next class.
Okay.